My name is Jordan Mingo, and I'm participating in Challenge 2016. In this presentation, I would like to show you how to solve a calculus problem. So our problem is to find the second derivative of our function y when y equals negative 3x squared times 3x minus 9 to the fifth power. So we have to solve this problem in two major parts. First, we must find the derivative of y. Then second, we must find the second derivative of y, or the derivative of the derivative of y. Before we get to these steps, however, I would like to teach you the fundamental concepts needed to get to the answer: the product rule and the chain rule. I will be going over the product rule first. The product rule is how you find the derivatives of product functions, such as the function shown on screen. We can separate this function into two components, 3x and 5x plus 3. For this example, 3x will be equivalent to f of x, and 5x plus 3 will be equal to g of x. So to utilize the product rule, you have to follow this method. To find the derivative of a product function, you have to combine f of x and g of x in a way that the derivative of y equals the derivative of f of x times g of x plus f of x times the derivative of g of x. So using the product rule, we can solve our example function this way. The product rule is a great tool to use for solving certain types of derivatives. Now that you have learned the basics of the product rule, it's time to learn another efficient technique, and that is the chain rule. The chain rule is used to solve derivatives where power functions contain an expression that could be its own separate function. For example, take this function that is on the screen right now. I will set the inside expression, 5x squared plus 2x, to g of x, and I will set f of x to x squared. It is not possible to use the product rule in this case because both component functions are not immediately explicit. To use the chain rule, one of the two component functions will be explicit, and as I explained, 5x squared plus 2x will be g of x. The other component is implied. This implicit component function it's not x squared, it is x cubed, which we will call f of x. The chain rule then goes as follows. The derivative of y for a chain rule function is the derivative of f of x, which contains g of x, times the derivative of g of x. So when solving our example, the solution becomes easy. The chain rule is another great tool for solving special derivatives. Now that you know the fundamental concepts needed to solve our original problem, let's get going. Our first step to solve our problem, negative 3x squared times 3x minus 9 to the fifth power, requires both the product rule and the chain rule. So we must first find the first derivative of our function y, and it should look like this. Our second step requires us to find the second derivative, which will be our answer. Finding the second derivative is as easy as taking the derivative of the first derivative that we just found. The answer to our question is shown on the screen. This problem is a perfect example of how you can combine different calculus concepts to make solving complex derivatives easier. This concludes my presentation. Thank you for watching.